Okie doke. Should be back again for Advent of Go 2022, day 10 into the double digits. Getting more comfortable with this whole streaming thing, so I'm not starting the stream a whole 3 minutes before and just assuming that the stream will launch properly sometime into the solve. Yesterday was an improvement from the past couple of days, but we're still not cresting that top 100 anymore, so maybe spending like 10 more seconds, 10 to 20 more seconds thinking about an implementation before just jumping in and coding something would do us some good. I'm curious. Oh, the screen did that black flickering thing again. I did that like 3 days ago. And that's not just on the stream. When that happens, like my actual whole display goes black as well. So hopefully that doesn't break stuff while solving. I used to have an even worse problem where my entire computer would shut down when I was doing it the past couple of years from running it on a Hackintosh partition. No, at least that's not happening anymore. But if, you know, my whole screen goes black during a day, I guess I'm done. I could just blind code it, maybe pull up the problem on my phone and code it because I have an auto submit, but we'll see. Anyways, jumping into the day, hope it goes well. It's a VM. There's something weird going on. Okay, I see. First, third cycle, X is still 1. Okay. Program counter advances. Look at the X value during execution, signal strength. It's like 6 things, right? Does it add first? Is it at the start of cycle? during. I wonder if this is right. Okay, oh, I see. Times. Print, counts. Twenty, 21, 20, and then on 60 you should be doing something. Oh my god, times 40. 1140, 1400. Something is up here. 60, 100. Are we off by 1? Should we start on cycle 1 like that? Do we loop at the end? Okay, what's going on here? Cycle 220 should be outputting something. Oh. Of course. That looks right, so... day sum counts. Right? Should be... Part 2. Okay, here we go. So it's rendering something. Single pixel each cycle. So carefully time the CPU. What? Oh, it's printing stuff. That's cool. So how does this work actually? A single pixel on each cycle based on if the sprite is positioned such that one of its 3 pixels what do you mean one of its 3? Okay, that's fine. Single pixel, representation pixel. Here are the cycles during which the first if the sprite is positioned such that one of its 3 pixels is the pixel. Am I just not able to interpret what this means? Oh, wait, I think I understand what's going on here. It's going across. It goes up to, okay, I see. Okay, so the width is 40, so if so it's if regs x, and it's at starts at position 1, so it's the sprite is here, so that gets drawn, and then it makes a new row, I guess. If cycles mod width is equal to 1, then so we're on the current cycle here on 1, and we just want to check if it's overlapping, right? So if if regs x is less than or equal to, it has to be either the cycle count, so cycles, I guess -1 mod width is less than, let's do this, and you can go up to cycles plus 2, then cur.append this, else we do this, and then if at the end, then we do a reset, right? So during the cycle it draws? So should I be subtracting 1 actually? Give me... Who knows if this even runs? That doesn't seem right. Oh, of course, we need to do that, right? This is like kinda, I think we're doing some, we're gonna need to do some printies here. We don't care about you anymore. We want to know what the values of regs x is and the values of cycle is. So cycles is 2, so I should be subtracting 1 from. Maybe we'll just do this. Oh, and we should be modding, right? This should also be, this should be C+3 mod width. Not quite. So we're on cycle 1, we the sprite is here, so we drew. Oh, we draw first, and then it moves. So here we wouldn't go. I see. Oh, and 1 is actually here. So we should draw first, and then change the value, I think is one of the problems. The other problem is that we want to be either equal to, we're on cycle 0, so okay, maybe we don't actually have to subtract 2, maybe we just subtract 1. So C mod width is less than or equal to, what is the value of regs here? So the register is 1, and we're on cycle 1, so we should definitely be drawing. We don't subtract. We draw here. We should also be drawing here because the register is 1 and we're on cycle 2, right? So this is our cycle count, so we should definitely be appending. Cycle count is 3, which is 2. If our cycle, if we're looking at number 2, the sprite, oh, the sprite position is, oh, I have this backwards. Whoops. It should be this way, registers, and we, no, wait. Okay, I actually have, my brain is having too much difficulty processing what this means. If register X is 16, this is our window. Oh wait, no, yeah, it is reversed. So this should be regs X, and this should be regs X plus 3, or maybe plus 2, because we're doing less than or equal, and this guy should be cycles mod width. Oh. So, draw, blank, blank. I mean, that's closer, right? Blank, blank. Here, we should have moved we finished executing minus, so it should be 5, so we should actually draw. So it's the ordering that's messed up now, but I think I have the logic here right. So let's just do this and see what happens. Oh wait, why do I have an extra add? Oh, that was definitely messing me up. I think that's right, and we don't have this add here. Jaw jaw blank blank, jaw jaw blank blank, cool. So now let's get rid of that. Let's get rid of that. We drew something, cool. Now we run this again, and we get something messed up. I'm pretty sure it's supposed to be P, but let me just try. We're like offset, right? Oops. PHLHJGCA. Ooh, very slow on today. Let's just take a quick look at the leaderboard. I can't tell if I got points on part 1 or not. I wasn't actually paying attention. Probably not. I feel like I was quite slow. Yeah. Personal stats. 263, and then we were too slow at adapting for part 2, unfortunately. Oh, well, that's okay. I will jump into the future, and then we can talk through this problem. So, we do this. Okay, we should be back now. Yeah, today was also an interesting problem as well. Didn't leaderboard again, and took way too much time for part 2, but I do think it's a cool problem. So for day 10, today's problem is called cathode ray tube, good old CRT televisions, and it's our first spoiler of a problem that looks like an instruction set for a virtual machine. So hold on, let's do this. Hello, 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 tippity tap, yes. So I think music should be off. We make the display bigger. So yeah, let's walk through this problem. So there's something about CRTs, and we're given a very small instruction set, basically. The program consists of either a no-op or add x and then an argument, a number. So the interesting thing about this question compared to all of the kind of simulation questions in past years is this concept of cycles. So now we have a machine that not every instruction takes one cycle. And so that's sort of interesting. Mark my words, I bet there will be a problem later in Advent of Code this month where we have to code up more of this virtual machine, and then there'll be a problem where we have to run many machines in parallel, and the fact that different instructions take different amounts of cycles to complete will cause some interesting parallelism between the two machines. This is just a spoiler for Advent of Code. I'm going to be spending a lot of time thinking about this abstraction over this machine and how to, I guess, surface the sort of information to make it easier for future problems, but that's besides the point. Let's just answer the problem at hand here. So we want to figure out the signal being sent by the CPU. The CPU only has a single register for now, x, and x begins as 1. So this was technically unnecessary, defining this as like a dictionary of registers. I could have just as easily said x equals 1. And actually, maybe it'll just be easier to do that for the sake of solving this problem. So we'll just do that as we go. This is our single register x, and it starts with the value 1. And so the two operations that can happen are a no-op and add. So the no-op takes one cycle, and it doesn't do anything. Add takes 2 cycles. So the first cycle, nothing happens. The second cycle, x is increased by whatever the argument is. So You might be asking, and I was asking myself while trying to read this question, why does it matter that add takes 2 cycles? Well, it's first of all, in part 1, we want to figure out what is the value at x during the 20th, 60th, 100th, and etc. All of these different cycles of the program. Note that it's not saying instruction 20, instruction 40, or whatever. So that's why it's important to keep track of cycle counts. And so it's pretty straightforward. We start with PC is just what I call the program counter or like instruction counter of which instruction are we looking at, right? And I guess this isn't really cycles, it's the current cycle is 1, and our register is x, so initialize emulator, I guess. Then we want to answer part 1. So we want to figure out what are the interesting signal numbers, specifically these ones. I mean, I could have just hard-coded them, but here's another way to do it, which I wrote a bug in at first, so maybe I should have just said the interesting numbers are 20, 60, 100, 140, 180, and 220. Great. And here we should maybe call this something signal strength, right? And these are interesting cycles. Great. So what do we want to do? For every instruction, we want to grab the instruction. So we grab the current line. Ignore the fact that this is day. I'll change it later to just read file input. We want to split apart this instruction because it might be a no-op and it might be at x, right? So we split it apart and we look at what the operation is. If the operation is a no-op, maybe we should do this in a different order. We increase the number of cycles by 1. Add doesn't matter, so just ignore it. It's from part 2. And if the current cycle is in the interesting cycles, we want to read whatever is in register X and append the signal strength, right? And here, where is it defined? Blah, 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 blah. Was it here? The signal strength is the value in the register X and the current cycle number multiplied. So we're on cycle 20, X was 21, and so 420 is the signal strength here. So we want to append that to our signal strength. And then we increase the program counter so that the next time we loop around, we're looking at the next instruction later. In the case that we see an add x instruction, it's a little more sophisticated. So we want to look at the argument. It's going to be the second number here, and we parse it as a number. We will, remember, add takes 2 cycles long. In the first cycle, nothing is happening. But in the second cycle, that's when we actually do something interesting. So we increment the cycle, and then because a cycle ticked, we have to, let me just change these. Again, check if the current cycle is one of the interesting cycles. So we do that. And if it is, we do the same thing here. We just append that to interesting signal strength. But because add lasts for 2 cycles, we do, let's see, this is process first cycle of addx. And then here we'll process second cycle of addx. So on the second cycle, we increment the cycle count. Now we have to increment or decrement x by the argument. You know, if it's negative number, x will go down. So we do that. This is called argument now. And then we do another check if the current cycle is interesting. And if it is, we append it to interesting signal strength. And at the end of all this, we increment the program counter so that, again, we'll move on to the next add instruction afterwards. So if we comment this out and we just print signal strength, and we run this on the sample input. I think I can triple click here. This is cycle. Oh, let's be smart with Vim. We do this. I know how to use Vim. And yeah, so our strength here are 420. 110, 180, 2940, 2880, and 3960, which are what we see here. Great, so that's part one. So, and the answer is just the sum of these, right? So the answer to part one is just the sum of signal strength. Great. Now let's figure out part two. Part two, I started scrolling, and then this ASCII art scared me. But really all that's happening for part two is every single cycle, we look at where the X register is. And that determines the location of this sprite. And so you can think of it as an old school CRT TV trying to render an image. So the scan line is coming down, and you either choose to draw something in that position or not. This kind of confused me. I'm not sure if I'm supposed to understand what's happening from here, but I found this easier to interpret. So remember, the value of X determines where the sprite currently is. And basically what happens is on each cycle, we figure out what pixel we're drawing, and then we figure out if we want to draw something there or not. So on cycle 1, we look here, and maybe draw something here. On cycle 2, we're going to try to draw something here. On cycle 3, we're going to try to draw something here, etc. all the way across until we hit the 40 cycle. Then we move to the next horizontal scan line down and like go across here. So what determines whether we draw something or not? Well, we look at where the sprite is, and the sprite is 3 long, basically. So if X is equal to 1, it occupies spots 1, 2, and 3. If the sprite is overlapping the position of the pixel that's trying to be drawn, it will draw something on that pixel. Otherwise, it doesn't. So if you mentally overlay this image onto here, on cycle 1, we do draw a pixel here because the sprite is in the way. On cycle 2, we're asking, do we want to draw this image, right? Oh, was I off because we don't draw something until the end of cycle? Maybe that's so. If you notice while I was solving, I just guessed that the first character was a P because the stalk of the P was cut off. I'm now going to kind of move some stuff around so that my code doesn't break, and we can rename this add function to something more reasonable, like what's a good name? Naming's hard. How about draw pixel? And so maybe this will work better if I change where draw pixel is being called. But basically, after every cycle, we'll start the cycle, we begin executing the instruction, we draw a pixel, and then we move the X if possible. Was I doing that? Yeah, I was. Okay. So basically, oops, what did I do? After every cycle, we want to attempt to draw a pixel. So that's just what calling out to this draw pixel function does. And what is draw pixel doing? Maybe it's easier if we don't just use this global thing. Okay, yeah, honestly that probably makes more sense. Let's just draw directly to the terminal. So we don't need any of this cruft, and we just want to do this logic to figure out if we should draw a pixel or not. And so what do? We first need to figure out what vertical position or horizontal position on the CRT are we drawing. So that's going to be the current cycle count. I guess because oh, I see. I think it's easier if I do this and I increment the cycle count at the end, right? Because we're on that cycle. Only afterwards does the cycle count increase. this might mess up part 1, but I just want the drawing to come out correct. So what does the check look like? Well, if x, and I just out of safety did a mod width, but I don't think we need to. So remember the sprite is 3 long, right? So basically, if the current cycle modulo, oh, I see. The current cycle, we draw a position here. I want to take the mod and add it back. So let's compute the position of the pixel that we're looking at. It's going to be the current cycle minus 1 mod the width of the display, and then plus 1 again. This is to make sure that if we're on cycle, let's say 41, we're looking at position 1 again, right? So if x is less than or equal to a position is less than or equal to x, or is less than x plus 2, then we want to print a hashtag. Sorry, a pound symbol. I think I can do end and say don't do a new line. Otherwise, we want to print out a period to represent that we didn't render a pixel. And then here, instead of doing weird appendy stuff with our printing, we can just print and force a new line. If I guess the check here is actually if our current position is equal to the width of the display. So I'm just going to blindly run this and see what happens. Oh, we're on an infinite loop. What is going on? Boop, boop. Let's copy this. Oh, what am I doing? I can triple. Why are we hanging? I probably... Why are we hanging? We're incrementing the program counter. Shouldn't this be fine? I feel like this is fine. I didn't even change this much. What did I break? Oh, I turned this to... I screwed myself by doing a find and replace. Okay. This image feels wrong. It should be 2, 2, 2, 2, 2, 3, 3, 3, 3, 3. Oh, so it was kind of like a checksummy thing. So let's figure out where we went wrong. At every point, let us print out cycle and x and figure out what we're doing here. If cycle is greater than 20, let's just break out of this loop. So I feel like this is a debugging I was doing while trying to solve the problem. So we're on cycle. So first number is a cycle, and the next number is the value of register. So on the first thing, they're equal, so we draw. On the second thing, they're equal, so we draw. On this, we move to 16, so we don't draw. 14, we don't draw again. Oh, but it finished executing, so we're back to 5. Yeah, so we draw, then we draw. But something went wrong here, I feel, where we added 6. So on cycle 6, we drew. On cycle 7, wait. How come the number is just wrong? Register is now 11. Oh, no, it's right. So we drew here. Here's where it messes up for some reason. I wonder what is going on. This is some live debugging going on, which makes for excellent stream content, of course. TRT draws pixel in position 7, so we drew, no, draw, and the draw is the output of the previous command. So here we should have drawn, so here we should have drawn because 10 is within 3 of the 8. So I'm pretty sure it's just a problem with the inequality here. Oh yeah, I made it a strict inequality here, but I didn't bump this number up to 3. Remember that the sprite is 3 wide. So yeah, it's on, off, on, off, on, off. And so I'm pretty sure now if we go and don't break and just print, does this look correct? 3s, 4s, 5s, I think so. And if we run this on the full input, oh great, we get the output. So on this input, on the real input, we get something that like spells out letters, always cute little problems to submit the answer to, because you can't just copy paste it. You could write something to kind of OCR it, I guess, but you just get to type it in the end. So yeah, that's pretty much this problem. So we don't have to do this printing anymore. I guess we can draw a new line at the end. But yeah. Okay, and I guess just to complete this, we can just convert this into, you know, something that works generally. I guess, honestly, we don't even need to keep track of the program counter. We can just do for line in file input.input. We do that. We don't need to keep track of the program counter at all. These are just constants. Yeah, because we're just handling both the cycles in a single loop. So this probably works. Let's do a python 3 day10.py pipe in input /10.txt. Cool. Yeah, so, you know, simple program that doesn't need any dependencies, but it was another interpreting instructions problem. I'm going to be probably spending at least an hour trying to figure out what other instructions could be added and how to abstract away this multi-cycle thing so we can run a couple of these instances of VMs in parallel. But yeah, excited for future VM questions. I hope it's not bait and then that this doesn't come back again. But yeah, unfortunately, again, not leaderboarding, but we will keep persevering. I told myself my personal goal is to try to break 1,000 points this month. I think that would be pretty great. Or stay in the top 50, which we are still in, even though we've gone on a bit of a dry streak in terms of gaining points. But yeah, that was the stream for today. Thank you for watching.